ENA cam phasing systems enable adaptation of valve timing to engine load and speed. Cam phasing systems can be applied to engines with single camshafts, OHV or OHC, or double overhead camshafts, DOHC. The advantages of applying camshaft phasing to an engine are improved fuel economy, emission reduction, improved low-end torque, and improved combustion smoothness, especially at idle speed. The cam phaser consists of the main components rotor and stator. A bolt firmly connects the rotor to the camshaft. The stator is connected to the crankshaft via the cam drive sprocket. The stator is radially supported on the rotor. Both components can be rotated against each other. Oil chambers are formed between segments of the stator and vanes in the rotor. One set of oil chambers works to move the timing towards retarding the valve timing. The other set works to move timing to advanced. Two covers seal the oil chambers axially. The base position stator and rotor are fixed to each other by a locking pin. This assures no noise during engine start. The base position of the intake cam phaser is at maximum retarded valve timing. For the exhaust phaser, the base position is at maximum advanced valve timing. Additionally, the exhaust phaser has a return spring. This cam phaser is the world's first mass production phaser made in sheet metal technology. Compared to a cam phaser in powder metal technology, this design has reduced mass and reduced mass moment of inertia. The cam phaser is controlled by the oil control valve. The oil control valve consists of a proportional solenoid and a hydraulic section. Inside the hydraulic portion, a spool moves axially. It opens and closes the ports. The spool is moved by the solenoid force against the counteracting force of a spring. Additional screens can be mounted to the valve ports to prevent contaminants from entering the valve. Despite their compact size, the oil control valves provide excellent control performance. The cam phasing system is supplied with oil from the engine lubrication system. To change the cam timing, the engine controller sends an electric current to the oil control valve. The solenoid changes the position of the hydraulic spool and pressurized oil is supplied to the cam phaser. During engine start, the cam phaser is mechanically locked into its base position. With increasing oil pressure in the cam phaser, the mechanical locking mechanism is released. Due to different oil pressures in the oil chambers, a relative rotation is induced. The cam timing position is changed. By changing the electric current to the solenoid, the relative rotation can be stopped in any timing position, or it can be reversed. The shifting velocity in either of the two directions can be modified by means of a compensating spring. This is used for the exhaust cam phaser to support its movement into the base position. The ENA cam phasing system has a robust design with low oil leakage and allows high shifting velocities. Our name represents precision and components for maximum value added in automotive development.